Hi guys, welcome back to my channel Vigyan Jyoti. So today's topic is current. Okay, so from the last videos we have come across the structure of atom, the flow of electrons. We have also seen how these electrons are responsible for the flow of current, right? Because if that means then how is it related to current, and why are we using, if the electrons are flowing, then why are we using this word current? Okay, so before understanding why is the electron responsible for the current and what is current, why is electron important in the topic current electricity, before that we should know what are the terms and units of current. Okay, so first of all, electric current is defined as the rate at which charge flows through the cross-section area of a conductor. Okay, so now we will come to this point, that is, what is the meaning of, right? What is the meaning of this word rate, these various terms? We have to understand each and every term. First, electric current is defined as the rate. So whenever we come across the word rate, that means we are trying to measure something with respect to time, right? So whenever we come at rate, now if I say at what rate you can solve your homework, that means what? At how fast you can solve your homework or how slow you can solve your homework. So this is the meaning of rate. Rate means something that we try to measure it with respect to time. Okay, so that means here another factor comes into the topic, that is time. Now what is it? At which charge flows. Now charge means I'm talking about Q equals to Ne. That means charge is what we know, the product of the number of electrons and the charge present on one electron. Okay, so this amount of charge is how much amount of charge is flowing through the cross-section area of a conductor. Okay, now if I say that in 10 seconds, my 50 coulomb of charge is flowing. Let's say, okay, if I say in 10 seconds, 50 coulomb of charge is flowing, then how are we going to define what is current? Current says at rate. Rate means, that means we will be always interested in how much, that means again same story, unit. Okay, whenever we try to compare to quantities, to physical quantities, to understand the basic that, like let's say, if I say today that 2 mangoes cost rupees 32, then how many mangoes will, what is the cost for 5 mangoes? If I say this kind of question, we always try to go with unitary method. What is the meaning of unitary method? That is one mango. We always try to find out the cost of 1 mango. Similarly, current says you need to also find out that how much amount of charge is flowing in unit time. Now we know the SI unit of time is second, so that can be minute, hour, whatever, but it has to be unit. That means it has to be 1. So that means we are not concerned that in 10 seconds how much amount of charge is going. We are concerned with the fact whenever we are using by the word rate, or when we are trying to compare two physical quantities, we always go with the fact that in 1 second, in this case, in 1 second, how much amount of charge is flowing. So in 1 second, it will be definitely 50 divided by 10. That means 5 coulomb of charge is flowing per second. That means in 1 second, how much amount of charge is flowing? 5 coulomb. Now let's say this is a part of an electrical wire, okay, where I have cut it in a cross-section way. Now let's say this is the cross-section view. Whenever we say cross-section view, that means if you cut something like this, right? Let's say if the wire is like this, you're cutting it like this, you are seeing the top of the this one. What is it? The wire. It's like a circle. This portion, right? So this is the wire I'm talking about. So now through this particular area, how much amount of charge is flowing in 1 second? That is what is current. So that means 5 coulomb divided by 1 second. That means this is the meaning. So if we try to separate them, that means 5 into 1 coulomb by 1 second. So this is something that we are saying as 1 ampere. Now before going to the word, first of all, I would like to introduce Andre Marie Ampere. He is the one who has coined the SI unit of current. So this is something that it has been explained, that the rate at which the charge will flow through the cross-section area of the conductor. How much amount of electrons? Because we know one electron has 1.6 into 10 minus 19 coulomb. So how much amount of charge is flowing in 1 second? It can be 1 hour, it can be 1 minute, it can be anything. But the question is, it has to be unitary first. Second, that whenever we try to express something in physics or whatever it is, we always try to give a standard unit. So for the standard unit for time is 1 second. That means in 1 second, how much amount of charge is flowing? That we are referring as current. So let us see the definition of current. Electric current is defined as the rate at which the charge flows through the cross-section area of a conductor. So here we comes with the word charge, and here we are talking about the physical quantity, that is time. Now since charge is again a fundamental quantity, then time is a fundamental quantity. So that means current becomes the derived quantity, because we are trying to find out the ratio between these two physical quantities, and we are trying to form another new physical quantity that is known as current. Okay, so symbol we are saying as I. Now the SI unit is what is it? Ampere. Okay. Now what we have done in the previous numerical, that means we have divided this 50 coulomb by 10 seconds, right? That means we have divided charge by time. So this is something that we are referring as current. Okay, this is something that we are referring as current. Okay, that means 1 ampere, if I want to say that 1 ampere of current is flowing, that means we know that if we are trying to find out with respect to something, that is always need to be unit, that is 1 second, right? That means if we need to get 1 ampere, that means definitely the charge has to be 1 coulomb. So 1 coulomb, if the amount of charge, that is if 1 coulomb of charge is flowing through the cross-section area of this electric wire, right? If the charge, just a second, if the charge 1 coulomb is flowing through the cross-section area of this particular conductor in 1 second, we say that 1 ampere of current is flowing. Okay, so an ampere is 1 coulomb per second. That means if 1 coulomb of charge is flowing through the cross-section area of this conductor in 1 second, we are saying this one as current. Clear? So that means current is a derived quantity of which two fundamental quantities? Charge and time. And if you want to find out this ratio, then definitely current becomes a derived quantity. So this is a point to note that this is a derived quantity. Why? Because it is a ratio of two fundamental quantities. They are dependent. So current is dependent on the two factors. That is, one is charge, other one is current. Okay. Next. Okay. The current. Okay. So how do we measure the voltage? We measure the voltage with the help of a voltmeter, right? We measure it with the voltmeter. So we have seen, right? And we have also known that why we are using the voltmeter in parallel, not in series. The first question is voltmeter's job, or you can say the role, is to calculate how much amount of work is being done from this point to this point, right? That means its main prime sole work is to find out the potential difference between 2 points. Now, if the voltmeter itself comes in between this path, that means the voltmeter is adding the job. That means the work has to be done through the voltmeter also. Then who will measure the job of the work that has been done through the voltmeter? So for that reason, it has to first of all come to parallel. Next, since we are providing two pathways for the electrons when we are connecting voltmeter in the parallel, the electrons will have two choices to go to the circuit. That is, one through straight normal circuit and other one is through voltmeter. Then voltmeter has decided that I need to put a high resistance so that electrons don't flow through me. Means electrons, huge amount of electrons, if it's flowing, that means huge amount of current is being drawn by the voltmeter. So for that reason, the voltmeter needs to have high resistance so that current does not flow through it, or maybe the minimum is a very negligible amount of electrons will flow through it, and the maximum electrons will flow through the other way, and that will make a complete circuit and we can easily do our job, that is to measure the potential difference. Now, how are we going to measure the current? How much amount of current? Okay, so first of all, the current is measured by an instrument called what? Ammeter. The ammeter is always connected in series. Now here the question comes that why are we connected in series, right? Okay, so that means we need to measure how much amount of electrons are flowing through them, not the work done. Okay, so if you want to experience that, let's say there's a luggage or a suitcase, you have to find out what is the what is the measurement, or the suitcase, what is the weight of the suitcase, or what is the mass of the suitcase. So then what you do? Can you see and just tell, yeah, that is the mass of the suitcase? No, you can't. Why? Because by viewing, if you don't feel it, how can you give me the measurement of the mass of the suitcase? That means you should experience it by yourself. So for that reason, if ammeter is not at all experiencing how much amount of electrons is flowing through it in 1 second, how can it help you in order to find out the current? So ammeter's job is to find out the current only if it can experience the flow of electrons physically. So for that reason, what we are doing? We are placing ammeter in series. Okay, we are placing ammeter in series, and this is how an ammeter looks. Okay, next, so when we are putting the ammeter in series, now the question comes here first, should it have low resistance or should it have high resistance? So what can you say? Yes, definitely, it should have what? Low resistance. Now, low resistance as in what? As in that it will try to obstruct the flow of electrons in a very less amount. That means there's no ideal case that you have to, even a bulb has resistance, but that's minimum, or you can say the negligible amount of resistance. Now, ammeter will have low resistance. Why? Because if it poses hindrance to the flow of electrons, then how will you measure that how much of electrons is flowing in 1 second? That means you need to cooperate with the flow of electrons. That means the electrons should move through this ammeter. That means it should have low resistance. Then the flow of electrons will be very smooth, and then you can easily find out that how much amount of current is flowing. That means how much amount of charge is flowing in unit time. So this is the reason why the ammeter is placed in series, voltmeter is placed in parallel. Ammeter has low resistance, voltmeter has high resistance. Is it clear? Okay. Now this is all about current. Now you may ask, or you may have a question in your hand, that why is the word again and again we are interchanging with the fact that still now I have stressed on the fact that there is a flow of electrons. Then what is this current? Current also has been defined that this much amount of charge flowing. Now you may say that means we were measuring the amount of flow of electrons, that means how much amount of electrons were flowing in unit time. This is something that we are saying as current. That means current is a concept, right? Current is not a physical body. That is not a physical body. That's a physical quantity. That is just a measurement. Now we have a question. We can have a question that then what is the direction of current and direction of electrons? Okay. Before moving to this, first of all, let us solve some numericals, and then we will jump. That is what is this direction of flow of the current, and what is the direction of this current? Okay. So first numerical as follows. Calculate the current drawn when 25 coulomb of charge is flowing through a conductor in 5 seconds. So we know the current is equal to, that means the ratio between charge and time. So charge is what? 25 coulomb, and time is how much? 5 seconds. So that means we can easily say it's 5 coulomb per second, which is 5 ampere, right? Because we know that 1 ampere is 1 coulomb per 1 second. So if I just segregate this to, that means it will become ampere. Very straightforward question. Okay, the next question. A current of 0.5 ampere is drawn by a filament of an electric bulb for 10 minutes. Okay. Now, find the amount of electric charge that flows through it. Okay. So, we know that Q by T equals to I, right? So, Q equals to IT. Fine. So, this is not your IT subject. This I here means current and T means time. Okay, so we don't know what is the charge. So but we know what's the current. That is, I is given as 0.5 ampere and time has been given as 10 minutes. Now we know that ampere is the SI unit of current, but for time it is not mentioned as a SI unit. There's a multiple unit. That's minutes, so we have to convert into seconds. So 10 into 60. That means because 1 minute 60 seconds, so it becomes 600 seconds. Now I is what? 0.5 and time is how much? 600. So 5 by 10 into 600. Do you understand why I have written 5 by 10? Because I'm just eliminating the decimal sign. Okay. This 2 is gone. So 5, 6 are 30. So 300. So 300 coulomb. So 300 coulomb is the amount of charge that is flowing for 10 minutes if my current is 0.5 ampere. Did you understand? This is also pretty simple. This is just like linear equations. Okay. Next question. Current of 10 ampere flows through a conductor for 2 minutes. Okay, so we have here sub questions also. So the first data that has been given to us is I equals to 10 ampere. And what is the time given? That is 2 minutes. 2 minutes. So if you want to find it in seconds, that means it will be 120 seconds. Okay, so this is how we should solve. Okay, always whenever you have data, jot them so that it will be easy for you to calculate. Just don't read the whole question at a go. One is like totally you read the question and you just come with what is the problem. No, always break the problem to sub problem. So first you jot down the data. Okay, given is a given data. Now the first question. Calculate the amount of charge passed through any cross-section area of the conductor. So I is given, T is given, means you have to find out the charge. So I into T. So what is 10 and what's the time? 120. So it's 1200. That means normal coulomb because we know the unit of charge. Okay, next question. If the charge of an electron is this much, that means 1.6 into 10 to the minus 19, 10 to the minus 19 coulomb. Okay, calculate the total number of electrons flowing. That means there's a question now related to charge. That means this time you have the current, you have the time, you found out the charge also. Now you have to find out number of electrons. So Ne is equal to the Q. Okay. So now, where is it? Yeah. Now, N we have to find out, that is Q by E. Now, what's my Q? 1200 coulomb. Okay. And what's my E? 1.6 into 10 to the power minus 19. Now, you may say we need calculator, not nothing. You just need to find out the common factors. Here is divisible by 4, divisible by 4. So, let us solve. So, 1200, 10 to the power positive 19. Obviously, it goes up. And I'll just add another 10 here so that I can make here 16. That's all. Okay. Now, 4 4s are 16. 4 3s are 12. And just we can put here 0 0, right? So, again here what we can do is 3 cross, I can make it as 100 and 10 to the power 19. Okay, let us make it as 20. So that, it will be easy. Because I have just added this 19 plus 1. Okay, divide by 4. Next, 3 into 10. Okay, 4 ones and 4, 25. So, 25 into 3 is how much? 75. So, 75 into 10 to the power 20 electrons. Can you imagine? That means in 10 ampere, right? In 10 ampere, how many electrons are there? There are 75 into 10 to the power 20 electrons are present in 10 ampere of current, or you may say in 1200 coulomb of charge, we have 75, after that 20 zeros, number of electrons are present. Okay, fine. We'll go to the next question. Oh, there's no more question. Now it's a circuit. Now we have seen this circuit before also, that where now the question comes here, if electrons are flowing in this direction, right? Now electrons are flowing in this direction, right? Because first of all, we have seen there's a power supply first. Next, there's an electrical wire which is conductor. Definitely, it can be made up of iron wire, copper wire, or silver wire, or whatever. That means it is conductor. Next, the switch is off. Sorry, the switch is on. That means there's no gap in the circuit. That means the circuit is complete. So the first thing what we have said, there needs to be a power source for the electrons to flow, because the electrons. Okay, next is there should be presence of free electrons. That means it should be conducting. The whole circuit needs to be conducting. Remember this. If one of the any part of the circuit is non-conducting or insulator, the flow of electrons will be barred. It will be obstructed. So as a result, the circuit won't be complete. So there has to be presence of power source to give the electrons one aim or job. You can say the guidance. Next is the conductor. That means everyone needs to have free electrons, or the space through which the electrons can easily flow. There will be less amount of obstructions. For that, we need the conductors. Okay, conductors means here we are talking about free electrons as well. Okay, and yeah, next is the circuit needs to be closed. Closed means what? As in, that means there should not be any case where the electrons are coming to a point and they are just like stopping. Now what to do? Okay, they should not get idle. The flow of electrons should continue. That means the circuit needs to be completed. Okay, there can be and in that case, if you see Resistance, as in, we'll come to the point resistance later on, but yeah, definitely resistance do play a role. But in this case, the basic factors which are very important for the flow of electrons to continue, that is power source, conductors, and circuit needs to be closed. Okay. Thank you guys for watching this video. If you really find this videos informative and helpful, please do subscribe my channel Vigyan Jyoti, hit the like button and share it with your dear and near ones. And yes, please don't forget to comment because your feedback does matter.